You know, if you've ever used a high-end gaming keyboard or controller, you've probably heard about Hall effect switches. They have this reputation for being incredibly precise, super consistent, where every single key press feels exactly the same. But have you ever stopped to wonder how that's even possible? Well, that's the fascinating puzzle we're going to solve right now.
Okay, let's just jump right into the core of it because this is the big question. We live in a world of mass production, right, where nothing is ever perfectly identical. So how on earth do manufacturers pull this off across millions and millions of units? It honestly seems impossible, but the answer is this brilliant mix of physics and some really clever engineering.
So here's our game plan for this explainer. We're going to start with the problem itself, what I'm calling the precision puzzle. Then we'll look at the super smart software solution, dig into why position is way more important than speed, and finally, we'll get into the fundamental physics, the real magic that makes it all work.
First up, let's really get our heads around the challenge here. The simple, kind of boring truth is that manufacturing is never perfect. Every single tiny component that rolls off an assembly line has these little, unavoidable variations.
I mean, just look at this list. There are so many things that can be just a little bit off. The sensitivity of the sensor itself can vary, the strength of the tiny magnets can be off by a few %, the physical alignment of the magnet and sensor is never going to be perfect, and hey, even the temperature in the room can throw things off. If you are trying to rely on absolute perfect measurements, this would just be a total disaster.
So how in the world do they solve this? Well, the secret isn't trying to build impossibly perfect hardware. No. It's about designing a system that's smart enough to just not care about those little imperfections. It is a classic case of working smarter, not harder.
And this, right here, is how they do it. It's so clever. First, the system doesn't care about the absolute strength of the magnet. It only measures the change as you press the key down. Second, there's a bit of on-chip logic called hysteresis. You can just think of it as a tiny buffer that ignores shaky little micro-movements so you don't get a flickering signal. But the real magic, the absolute key to the whole thing, is number 3, software normalization. The keyboard's brain automatically figures out the very top and very bottom of each key's travel, and then it just defines the actuation point as a simple percentage of that distance.
This quote just nails it. Because of that software trick, 2 different switches can be sending completely different raw data. One magnet might be a little weaker, the other a bit stronger, but to you, the person actually using the keyboard, they feel 100% identical. The software basically creates a perfect experience out of imperfect parts. So cool.
Now let's build on that, because there's another huge piece to this puzzle. Another reason these switches feel so darn consistent is because they are fundamentally measuring position, not how fast or how hard you press the key. And believe me, this is a massive departure from how older switches work.
This table just makes it crystal clear. With a classic mechanical switch, how fast you press can actually change the exact millisecond it registers. That's because of issues with the physical metal contacts bouncing around. But with a Hall effect switch, it doesn't matter. Whether you press it super slowly or you just slam it down, it actuates at the exact same physical position, every single time. And the reason why is right here. A Hall effect switch has no physical contacts that ever actually touch each other. This completely gets rid of a problem called contact bounce, which is basically just messy electrical noise that plagues mechanical switches. And without that noise, the system doesn't need complicated software to guess when you really press the key, which removes a huge source of inconsistency. And just to put the speed of this into perspective, a typical Hall sensor responds in 1 to 10 microseconds. A fast key press takes a few milliseconds. That means the sensor is literally thousands of times faster than your finger could ever hope to be. It makes the measurement feel completely instantaneous, totally independent of how fast you're typing.
Okay, so we've seen the clever engineering. We've seen the software tricks. You ready to peel back that final layer and get into the fundamental physics that makes this whole thing possible? Let's talk about how the sensor actually turns a magnetic field into a signal.
It all comes down to this one awesome principle, the Hall effect. Now, in the simplest terms, imagine you've got electricity flowing through something, like water in a pipe. If you bring a magnet up next to it, that magnetic field will literally push the moving electric charges over to one side of the pipe. And that little pileup of charges creates a voltage that you can measure.
So here's how it plays out step by step inside the switch. First, you've got a steady current flowing through a little plate. Second, you bring a magnet near it, which creates a magnetic field. Third, that field exerts a real physical force, it's called the Lorentz force, on those moving charges, shoving them sideways. And fourth, this separation of charges creates a stable, measurable voltage. And what's so crucial here is that the magnet doesn't even need to be moving for this to work.
This is a really important distinction.
A lot of us are familiar with induction. It's how electric generators work, right? But induction needs a changing magnetic field to create a signal. It's really measuring velocity. The Hall effect, on the other hand, works with a static, non-moving field. It's measuring position. And for a keyboard switch, that's exactly what you want.
All right, let's bring it all home. We've gone from manufacturing quirks to firmware tricks, all the way down to fundamental physics. So why does any of this matter to you when you're just typing an email or playing a game?
Well, the result of all that science and engineering is a switch that is just superior in almost every way you can measure. You get extreme repeatability, there are no physical contacts to wear out or degrade after millions of clicks. You get unmatched consistency from the W key all the way over to the spacebar, and its actuation is based purely on its position, which makes it incredibly predictable and reliable.
And if there's one thing you take away from this whole explainer, it's this. That feeling of precision that everyone loves isn't because every tiny magnet is perfectly made. It's because the system, as a whole, is perfectly repeatable, all thanks to that brilliant combination of physics and software.
It really makes you think, doesn't it? This whole idea of using smart software to compensate for the messy reality of the physical world is just so powerful. It totally perfected the keyboard switch. The only question left is, what's next?